Hello and welcome everyone guys, welcome to each one of you. Today's agenda is to revise the entire chapter sets of class 11th along with question solving. So initial part will be the summary notes of the chapter and the later half will be the question answers. I'll be writing down each and every point, the relevant ones, and make sure if you can note it down together, it will be great. Right, let's keep the session very crisp, clear, to the point, with the aim that you have already studied these chapter sets and you're here to revise it. Even if you have not studied, I guess most of the points you will be able to grab it because it's a very easy chapter. So without any further delay, here is the first point about sets. It is a collection of objects. It is a collection of what? Collection of well-defined objects. Well-defined, well-distinguishable objects. That means you're able to clearly separate the objects. For example, I say top 5 batsmen top favorite 5 batsmen. Everybody will have a different answer. So it's not well distinguished. If the answer for everyone remains the same, it's a well distinguished collection and it will be referred to as a set. These objects, my dear guys, these objects can also be referred as elements or members, and in some cases also points. Right, the third point that we studied about sets, introduction going on people. Sets are written in capital letters. Sets are denoted by capital letters like A, B, C, X, Y, Z, etc. Any letter that you like, you can use it to represent a set. Next. No repetition allowed in sets. No repetition allowed in sets. Fifth point, sets can be represented in 2 formats. What are the 2 formats? Everybody can write it down in the chat. The 2 forms are known as, yes, tabular form and set builder form. What are the other names for tabular form and set builder form? Tabular form is also known as, not rule, list method, because we form a list of objects. And set builder form is also referred to as the rule method. What happens in tabular and what happens in set builder? In tabular form, my dear boys and girls, we write the elements in curly brackets separated by commas. Right. In set builder form, we write it something like this: X, where X satisfies the property of set. X satisfies the property of set. So set builder form is basically based on the property. You might be wondering what it is for the first timers, but for those who have already studied it, you know what I'm talking here. This symbol can be replaced with a straight line also. Both mean one and the same, such that. Both of them mean one and the same, such that. Right, this was the basic introduction to sets. After the introduction part, we moved on to next portion, which is types of sets. So how many types of sets did you study? How many types of sets did we study? The very first type, null or void set. Null or void set. The name itself says there is nothing in this set, can be represented with a phi, Greek letter phi, or this curly bracket, right? Any one of the two. Do not try to write it like this. Do not try to write it like this. This is not your null set. Second type of set that we studied was a singleton set. Singleton set. Name itself says there will be only one element in the set. This is a singleton set. This is a singleton set. There is one element phi in it. Third one, finite, and correspondingly next one, infinite. The name itself clearly says it. Finite set is something which has countable number of elements in it, like for example 1, 2, 3, you can count it. Infinite set, points on a line. Can you count the number of points on a line? No, it's infinite. So fifth one, the fifth type was equal sets. What do you mean by equal sets? It is represented this way. when the elements of A and the elements of B are equal. The next one is equivalent sets, which means the number of elements in A should be equal to number of elements in B. In other words, the cardinality should be same. Cardinality should be same, right? Here the elements should be same, the objects should be same, and in the next one cardinality should be same. Please do not get confused between the two. The seventh type, the last type of set that we studied was disjoint set. Disjoint set means when the two sets have nothing in common. When the two sets have nothing in common. The questions on them are pretty simple, guys. So as we go ahead in the later half, we will see questions on them. These are the 7 types of sets. After sets, the topic that we encountered was about subsets, right? Subsets. What do you mean by subset? By definition, there are big things. All I need to know is when all elements of A belong to B, obviously set A and set B, then we say A is a subset of B, right? In subsets, there are 2 types that we study particularly: proper subset and improper subset. Proper and improper subset. Proper subset means when A is a subset of B and A is not equal to B. Example 1, 2, 3. Example 1, 2. This is your set A and set B is 1, 2, 3. Can you say all the elements of A are in B but A and B are not equal? It's a proper subset. What about improper? Improper means A is a subset of B and also A is equal to B. For example, A is 1, 2, B is also 1, 2. A and B are same. You will say A is an improper subset. To be more specific, a proper subset is written like this. Like in the first case, A is a proper subset of B, and in the second case, it's an improper subset. That means less than B, A is less than B, and A is less than equal to B, just for the purpose of understanding. Some pointers, guys, some pointers that we must know related to subsets. First, phi is a subset of all sets. Phi is a subset of all sets. Remember, any set, one of the subset is fixed, which is null set, phi set. If I say A is a subset of B, it also means A is a subset of B. It also means B is superset of A. B is what? Superset of A. B is the bigger set of A. So B will be superset, A will be subset. Subset smaller, superset bigger one, the larger one. Third point, total number of subsets. Total number of subsets. Suppose set A has P elements, then total number of subsets will be equal to, A is subset of B, right? Yeah. If n of A is equal to P, the formula is 2 raised to P. That's a formula for total number of subsets. Total number of proper subsets will be how much? And total number of improper subsets. As you can see, there is only one improper subset available. So where should I write? Next page? Yes. Total number of improper subset. One, always. So then in the end, total number of proper subset will be total subsets, total number of subsets minus number of improper subsets. Correct? 2 raised to P minus 1. 2 raised to P minus 1. That's all about subsets, right, guys? Okay. We will go to the next topic, which is power set. And now what is this power set? Power set, when you collect all these subsets together, you will get a power set. Collection of all subsets. Collection of all subsets is a power set, right? Number of elements in a power set will be how much? Suppose A set has again p elements. So number of elements in its power set will be same as total number of subsets, which is 2 raised to p, because total number of subsets is same as number of elements in power set. What after power set? A very small topic, which was universal set. Universal set is the collection of all the subsets. When you collect all the subsets, you get a universal set. Oh, sorry, my bad. Universal set. It is the biggest set for a given question. It is the biggest set for a given question. The biggest set for a given problem or for a given question. For example, in a school, there are first standard, second standard, third standard students. What will be the biggest set of all these students? When I mention all the students of school, all the students of school will be the biggest one. Students of standard 1, a subset of it. Students of standard 2, another subset. Students of standard 3, another subset. So multiple subsets, but only one universal set. After this, we also looked into the next topic, which was about intervals. Let's study about intervals, guys. What was the 4 types of intervals which we studied? Closed, wherein you write like this, square brackets. Open, round brackets. Right half open, right half open, also referred to as right half is open, also referred to as semi-closed, and left half open. Also referred to as semi-open, semi-closed, semi-open. What does this mean? It simply means that x is greater than equal to a, less than equal to b. Closed. Your open means x is strictly greater than a, strictly less than b. Close open, x is greater than equal to a, less than b. Open close, x is strictly greater than a but less than equal to b. LOI, there is something called as length of an interval. Length of an interval is nothing but when you subtract upper limit minus lower limit, b minus a. Be it any interval, when you subtract b minus a, you get length of an interval. This interval knowledge was important for upcoming types. After the subset, power set, universal set, interval notations, what did we go on? We saw in brief about Venn diagram. What is a Venn diagram? Venn uncle? Yes, Venn uncle helped us to simplify the questions of sets using his diagrammatic approach. So all we say in Venn diagram is, for a universal set, rectangle or a square is used. For subset, circle is used. And to denote any element, we use a point. Universal set can also be written as capital letter X, depends from situation to situation. After this, a very important part was started, which is operation on sets. Operation on sets. What kind of operation did we perform? The very first operation performed by us was union. What is A union B? The definition says it is all x where x belongs to A or x belongs to B. This or word is important. It simply says that take all the elements of A and B, combine them, that's the union. Second, A intersection B all x where x belongs to A and x also belongs to B. So all the elements which are common between A and B will be called as intersection. Right? Okay. With the help of Venn diagram, if we want to understand the union and intersection, let's quickly have a look at it. Two sets A and B given. Union will be simply, for union, you will shade all of A and B combined. For intersection, you will shade only this common area between A and B. If A and B are disjoint, separated, then there is nothing common between them. Right, guys? What was the third operation? These two operations, union, intersection. In case anybody gets confused, here when you write OR, this has a U in it, kind of, right? And when you write AND, it has intersection in it. If you can see, say this. Intersection in an AND and union, U in an OR. That was just like that. The third thing after union, intersection, we saw difference of sets. Difference of sets. Now difference of sets is denoted by A minus B, wherein the definition is it is all x such that x belongs to A and x will not belong to B. X does not belong to B. A minus B. Right. Fourth one was symmetric difference. Symmetric difference. Let's quickly go through all the notes, guys, so we are free to solve the questions. Then we don't have to worry about what question comes our way. Symmetric difference also denoted as A delta B. This delta is nothing but symmetricity, and it simply means A minus B union B minus A. A minus B union B minus A. What was the next operation, people? Symmetric difference done. Next operation after difference of sets was write in the chat. Union, intersection, complement, right? Complement of sets. Complement. How do you denote complement of a set? It's written as A to the power C or just A prime, right? And the definition of A complement is all x such that x belongs to universal set and x does not belong to A. So in other words, A complement is U minus A also. It's a part of universal set, but it's not a part of your set A. All those elements will be complement. Certain properties of union, intersection and complements are there, which we are going to see. For complement, one simple property. A complement, the whole complement is same as A when you take the complement twice. Right. Okay. Is A minus B equal to B minus A? Is the difference property commutative? No, it's not commutative. Next, we'll continue with the property A union B is equal to B union A, and similarly A intersection B is same as B intersection A. So that means union, intersection follow your commutative property. They both follow the commutative property. What about this? A union A is A. Also, A intersection A is A. This property is called as idempotent. The word idempotent means unchanged. A, everything everything A, unchanged. A intersection phi, we are here, this column is of union. A union phi is A, and A intersection phi, A intersection with U is also A. Can you see the input is A, the output is A? That means input output same. It's called as an identity property. It's an identity property. A union U, when you take the union of entire universal set with a set A, you will get universal set, and when A is intersected with a null set, we get a null set in return. This is called universal and null law. Universal and null law ni property. Right, kiddos? Universal and null property. Next one. A union B union C is same as A union B union C. And the same goes for intersection. A intersection B intersection C is same as A intersection B intersection with C. You're just changing the brackets and it is called as associative law, where you just change the brackets, intersection, 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 intersection. Same sign, associative law, union, 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 associative law. But if there is a difference, like this, union and intersection combined together, then it's not associative law, it's called as distributive law. I hope you know this. You just open the bracket, multiply the terms, A union B intersected with A union C. And similarly, if you have A intersection B union C, open the brackets the way you would open A intersection B union A intersection C. That's your distributive law. The next two, very important. Right. A union B, the whole complement is equal to A complement intersection B complement. Union becomes intersection and the complement splits. Also, A intersection B, the whole complement will be equal to A complement union B complement. Intersection becomes union and the complement splits. So basically, you're just changing the union to intersection and splitting the complement. That's your De Morgan's law, right, my dear boys and girls? And the important one. So these are the properties of union and intersection that are relevant to us. Right, people? What was the next thing after this? I think, the next thing after studying the operation on sets, we went to cardinality based problems. Cardinality based problems. For example, if there are two sets A and B, n of A union B is given by a formula n of A plus n of B minus n of A intersection B. N of A minus B is given by the formula n of A minus n of A intersection B. Can you imagine this in a Venn diagram? Try to imagine this. Also, n of B minus A is nothing but from the entire set B, you remove the intersection of A and B. And when there are three sets involved like A, B and C, then the formula turns out to be n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. The common of all three is being added. For Venn diagram of two sets, two circles A and B, the two circles are intersecting. You know what is the union. And for three sets, three circles like this. Guys, theory wise, this is all that we need to understand. This is the common area of all three, and the other of two you already are aware of. Right, people? So that's the theory part of this chapter. Let's go to the questions now. Let's go to the questions now. Here is the first question, everyone. Write the set of all positive integers whose cube is odd. Now, whose cube will be odd? All the odd numbers will have an odd cube. So obviously this set, if I say let set A be the given question, A set will have all the odd numbers like 1, 3, 5, 7 9. Did you know this already? 1 cube, 3 cube, 5 cube are all odd numbers. Where is all the even numbers will have the cubes to be even. Guys, they asked for positive integers, so I have written positive. Otherwise, there would have been -1, -3, -5 also. Well, right now not needed. Write the set in set builder form. So the previous one was tabular form or list method. This is the set builder form we are going to write in. Observe this carefully. 1 by 2, 2 by 3, 3 by 4, 4 by 5. I can say it is a set of all x such that x is forming a formula like this, n upon n plus 1. And what is n? N belongs to natural number. And are we taking all the natural numbers? No, we are taking from 1 to 8. So n should be less than or equal to 8. No need of writing 1 because natural number anyway starts from the number 1. So you take the values of n should be less than or equal to 7. Because last n is 7. 7 upon 7 plus 1 will get 8. Right guys, right. Check. Put n from 1 to 7 in this formula, you will get the needed set. Next question. Write the set x such that x is positive integer, x square is less than 30 in roster form. We need to write this in roster form. My dear boys and girls, all the numbers, all the elements, all the x's whose squares will be less than 30. 1, 2, 3, 4, 5. That's it. 5 square 25, 6 square 36. It will cross 30. We are not going to cross 30 anyways. Write this in set builder form. So enough practice for roster set builder. 0, 1, 4, 9, 16. Careful. It is all x such that write the property of x which will satisfy this. It is all x such that x is equal to n square and n belongs to whole numbers because it's starting from 0. That's one way. Or guys, there can be other way also to write. B is a set of all x square such that x is nothing but your whole number. We can directly write this way also. It's absolutely right, one and the same. This dot dot means it's an infinite set. State which of the following are finite and which are infinite. Check all four one by one. The first one, x is natural number, x square minus 3x plus 2 is 0. So try to find x. Try to find x by solving this quadratic equation. X minus 2, x minus 1 is 0. It implies x is equal to 1 and 2. That means the first set A has two elements 1, 2. It's a finite set F. The second set, x natural number, x square is 9. When we solve, x will be plus or minus 3. But the set B will only have plus 3. Why? Because we said x should be natural number. So minus of 3 is discarded. B has only one element. Again, this can be regarded as a finite set. A finite set. F for finite, I for infinite. I hope you understand. X belongs to natural number and x is an even number. All the natural numbers which are even. Oh my god. This set C. 2, 4, 6, 8, that means it's an infinite set. Even natural numbers. Last one, x is natural number, 2x minus 3 is 0. When we solve this, x is 3 by 2. That means set D has only one element. It's a singleton set. I can also qualify it as a finite set. So out of the 4, only 1 infinite, 3 finite. Hope so it's clear. In the next question, you are going to figure out the empty or null or void sets. Different names for the same set. First one, set of odd natural numbers divisible by 2. Odd numbers. What are the odd numbers which are divisible by 2? Oh. Odd natural numbers, nothing. It's a null set. X is greater than 3, less than 4 and x is a natural number. So what are the natural numbers between 3 and 4? No natural number. Again, empty. X square is 25 and x is an odd integer. When I solve this, I'll get x as plus minus 5. Both are odd integers. That means the third set has two numbers, minus 5 plus 5. Is it empty? Not empty. 5 is an odd number. X square minus 2 is 0. X is rational. When I solve this, x will be equal to, x square is 2, x will be equal to root 2. It is irrational, my dear boys and girls. It is irrational. So what is there in the set? There is nothing in the set. There is absolutely nothing in the set. On solving this equation, I don't get a rational number. It's an empty set. And x is common point of any two parallel lines. Nothing is common between two parallel lines. Again, it's an empty set. So either phi symbol or this curly bracket will denote an empty set. Next, find the pairs of equal sets from the following. Okay, this was not needed anyways. Fine. A, B, C, D, E. Right, we didn't do equal sets. We did finite, infinite. We did null, singleton also we saw. Equal sets, let's do it. A is single set, B, singleton set. B is x greater than 15 and less than 5. So what will the B set include? They have not mentioned what x is. X is natural number, whole number, odd numbers, even numbers, integers, what? Or x is real number, they should have mentioned, right? Let's assume here x is real number. And then all the numbers which are less than 5 and greater than 50, anyways, it's going to be empty. It's empty. C, lol. X minus 5 is 0. Once again, they have not mentioned what is x. Still, it's only 5. D, x square is 25. It can be plus minus 5, or let's separate and write minus 5 and plus 5. E, x is a positive integral root of this equation. If you solve this equation, what is the value of x that you are getting? 15. 3 5s are yeah, x minus 5, x plus 3 equal to 0. That means x equal to minus 3 comma 5. So E set has two elements, minus 3 and 5. Okay, A is already there. A is not empty, yeah? It's singleton. Which of them are equal sets? Check, check, check. D, x square is 25, x is minus plus 5, right? I have not, positive integral root. Here, positive integral root. This is the catch. If they say positive integral root, I will not write minus 3. I will not write minus 3, but just plus 5. Minus 3 will be discarded. And from here I can see C set is equal to E set. C is equal to E. Anything else? No. If I ask you equivalent sets, then you have to check for cardinality. That means the sets which have equal number of elements. A, C, E. All three of them have equal number of elements. And we can write A equivalent to C equivalent to E. This is the symbol for equivalent sets, right? The wave, which shows number of elements are same, cardinality is same. X is letter of English alphabet for set U, and A means X is vowel in English alphabet. What will be A complement and what will be A complement's complement? Easy peasy lemon squeezy, easy peasy lemon squeezy. X is letter of English alphabet A, B, C, D, E, F, G, H till Z. A vowel of A, E, I, O, U. In my generation, this was the vowel. Has it changed in the gram generation? I don't know. Well, what will be A complement? It will be U minus A. So from all the alphabets, if you remove the vowels, you will get the consonants. You will get all the consonants, right? And again, if I take its complement, that is U minus A complement. A complement is U minus A. So A complement's complement will be U minus A complement. That means from all the alphabets, if you remove the consonants, alphabets minus consonants, we will get the vowels, that is A. right? A is your vowel. So the property is also verified through this question. Next, A1 is given, A2 is given, A3 is given. Find union of AI, intersection of AI, where I is 1, 2, 3. Now what does this mean? I is denoting that you have to find the union of I is replaced by 1, 2 and 3. That means A1 union A2 union A3. Similarly, intersection of AI, you replace the I with 1, 2, 3 as given. A1 intersection A2 intersection A3. This is what is asked in this complex looking simple question. 2, 3, 4, 5. Union means I am simply going to write all the elements 2, 3, 4, 5, 6, 7. Right? If I am missing anything, please excuse me. And when I say intersection, I can see here the intersection between first two is 3, 4, 5 and then 4, 5. Only 4, 5 guys. 4, 5 is common between all three of them, not just two of them. All three of them, we are checking the common part. Question done? Right. Very good. A, B given, find A minus B union B minus A. Isn't it symmetric difference? Isn't it the symmetric difference? Right. When I talk about A minus B from the set A, I am going to remove the elements of set B. All the elements of B are removed from the set A. So what can I remove from set A? 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8. I can remove this 3, 4, 5, 6 from here and A minus B will be 1, 2. Similarly, B minus A means when I remove all the elements of set A from set B. When I remove all the elements of set A from set B. B minus A. Now what are the elements of set A already present in B? 3, 4, 5, 6, 7, 8, 3, 4, 5, 6. So I remove this 3, 4, 5, 6 from set B. We will be left with 7 and 8, isn't it? 7 and 8. In the end, all you have to do is take their unions. 1, 2 unionized with 7, 8. What will the answer be? Why it's not right? Let's wait. This happens at times when the teacher does a lot of work, you know. You see I'm doing a lot of work. Yeah. 7, 8. The answer to this symmetric difference is 1, 2, 7 and 8. That's it. Done. Good. Few more questions, people. Few more questions to say that yes, the chapter is well done. Now these kind of questions can be proved using Venn diagram or can be proved using properties, the laws that you studied. The best Venn diagram, of course. If they've mentioned that prove using Venn diagram, then definitely Venn diagram you have to use. If they mention that proof, that's it. It's your choice. You can go by properties or Venn diagram. Would you want to go by properties? Let's do it by properties. Fine. What is given? LHS. A intersection B minus C. Property is like just playing around, you know, making fool. A intersection B minus C. Remember, intersection stands for and, union stands for or. Okay. So let X belongs to this. Let X belongs to A intersection B minus C. What does this mean? It means X belongs to A and X belongs to B minus C. In other words, X belongs to A and X belongs to B and X doesn't belong to C. That's what it means, right? This single element, if not written in bracket, it's fine. X belongs to B and it doesn't belong to C. Now use the distributive property. Use the distributive property. X belongs to A and X belongs to B. Then there is a minus sign. Okay. Also, X belongs to A and X doesn't belong to C. Here this first part when you cover, this says X belongs to A intersection B. And here it says, because there's a does not belong to sign, X doesn't belong to A and X doesn't belong to C. That means X doesn't belong to A and C. X belongs to something, does not belongs to something. That means X belongs to A intersection B but not to A intersection C. First step, last step. If you combine the first and second step, it's proved. It's proved. LHS is equal to RHS. Can you see this? I'll recap it quickly. X belongs to A, X belongs to B minus C. That means belongs to A, belongs to B, doesn't belong to C. Now remember that this does not belong to will be used in distributive property. This and when you multiply. X belongs to A and X belongs to B, and X doesn't belong to A, doesn't belong to C. Because of this does not belong to sign. Belongs to A and B, doesn't belong to A and C. Belongs, doesn't belong. Doesn't belong means minus sign. Remember this minus sign doesn't belong, right? So minus sign doesn't belong. Hence proved. Hence proved. If it has to be proved using Venn diagram, all you will do is draw multiple diagrams. Do you want me to do it? Let's do it. A intersection B minus C is equal to A intersection B minus A intersection C. It's the distributive property that they are trying to prove. First we will draw B minus C. Then we will draw its intersection with A intersection B minus C. That will be your LHS. For RHS, how many diagrams are needed? First, we will try to draw A intersection B, then A intersection C, and then finally A intersection B minus A intersection C. All three combined. Right, people? Okay. Let's see if I'm getting something similar. The diagrams are going to be not, I'm not using geometrical shapes and all to draw the diagrams. Let's not waste time here. Let's try to save as much time as possible, because it's a one short video kind of, wherein you're here to just revise, not waste time into stories. B, C. Alright guys, let me use a different color. B minus C, that means from the set, entire set B, you will remove the set C. Wherever there is C, you are going to remove that. So this is what I get roughly. Try to understand please. Then take this green portion, you have to take it common with the A circle. So what is common between the A circle and the green portion? Between this A circle and this green portion, only this much part is common, right? This upper triangular part, right? This is what I get, the LHS. RHS, A intersection B, common between A and B is this portion, the full, right? A intersection C, common between A and C, this part. Now, from this green, you have to remove this green. From this green part, portion, you will be removing this green. Essentially, I will be left with this upper triangular part. Try to understand this. If you can understand, great. You are done with this question. Hence, we can say LHS is equal to RHS. Hence, proved by Venn diagram also. So clear how easy Venn uncle made the sets for us. Otherwise, it's just, Next question. Prove the following: A minus B is A minus A intersection B, where U is a universal set. Why is U mentioned anyways? LHS. A minus B, so that means any element X belongs to A minus B. If X belongs to A minus B, it implies that X belongs to A and X does not belong to B. Now next step, you have to note, it's important. X belongs to A and X belongs to A. Can I write it like this? Any problem? And X does not belong to B. I hope no one has a problem with this. X belongs to A, X belongs to A. What's wrong in it? Why am I doing it? Let's use the associative property. What does associative property says? Remember union, union, union? We just shift the brackets. Intersection, intersection, intersection. Just the position of bracket shifts. Nothing else. So here also you can see and. I'm just shifting the position of bracket. X belongs to A and X belongs to A, X doesn't belong to B. The first part, X belongs to A, that means A, and I am supposed to write this, A and belongs to A doesn't belong to B means A minus B. That's the definition of difference of a set. What is A minus B? When X belongs to A, doesn't belong to B. Right? Can you, LHS is equal to RHS? Hence proved using the property. Similarly, by Venn diagram also you can prove. A, B, C are three sets such that A intersection B is equal to A intersection C and A union B is equal to A union C. Then which option is correct? Is A equal to C? Is B equal to C? Is A intersection B equal to phi? Or A is equal to B? Okay. Interesting question, important question, right? For those who had the patience to watch till the end, you're going to learn some really good things. If you want, you can imagine this through Venn diagram. Well, there is no role of Venn diagram as such to solve this question. All you have to do is use the properties and understand. Okay, these two things are given to us. Let us first assume a case. Let's suppose, how come let's suppose both together? Suppose X belongs to C. There is an element X which belongs to this C, right? Now let that X also belong to A. So assume that the element belong to C, and now in the C circle assume that it also belongs to A. So can I say that X belongs to the intersection A and C, right? If it belongs to C as well as A, it belongs to the intersection. Now what is A intersection C equal to? A intersection C is equal to A intersection B. So can I also say X belongs to A intersection B given? Now if there is an element which belongs to C and it belongs to A, it belongs to the intersection. But now I said A intersection B is also equal to A intersection C. That means that elements also belong to B, which implies X will also belong to B. If any element belongs to its intersection, then it will belong to that particular set also. X belongs to A, X belongs to B. We started by saying that X belongs to C. We concluded with the statement X belongs to B. What does these two statements tell us? If any element belongs to C and it also belongs to the other element B, what does it say? It simply tells us it's a definition of subset. What is a definition of subset? When do you say A is a subset of B? When X belongs to A and it also belongs to B. So here X belongs to C and also belongs to B. We can say that C is a subset of B. C is a subset of B. Guys, using the same logic, you can prove vice versa. You can easily prove vice versa. That means you will now be requiring this part. In the first section, I used this. Here I used A intersection B is equal to A intersection C. In the next part, you will be using the union property and you will be able to prove that B is a subset of C. And when two sets are subset of each other, isn't it a property? Like A is a subset of B as well as B is a subset of A. Both are subsets of each other. It simply means A is equal to B. It's a property. So here also we can see that B is equal to C. B is equal to C, which is option number B. Try to understand, take your time, imagine, pause the video, go through it again, think about it. You will be able to understand. Believe the last question, prove using Venn diagram. So yeah, chill of 5. A minus B is A intersection B complement. Did we do this already? No, we didn't. So in the first question, I am trying to draw the LHS, which is A minus B. And in the first question, if I try to draw the RHS, what all things are needed? First A minus B. Then we take its union with another circle B. And we get the final, oh my god, RHS is A intersection B complement. RHS is A intersection B complement. I went to the LHS of other question. So first diagram should be B complement. And then A intersection B complement. We'll take its complement with A. We'll take the complement of B with A. Right? So here there is A minus B, A intersection B complement. We'll compare if our LHS is equal to RHS or not. And in the second question, LHS will be first A minus B. Nice drawing, yeah. Union with B. That's LHS. Moving on to RHS, it's A union B. Simple. A union B we know already. And then we will check whether LHS matches with the RHS or not. First one, how do we shade A minus B? Everybody, A minus B. From A you will remove B. This is what is left. From A if I remove B. B complement. B complement means from universal set remove B. That means everything in the universal set will be marked except the circle B. Everything outside of the circle B should be shaded. A intersection with B complement. Now there is A, this circle A, entire circle A, and you have to take its intersection with B complement. What will be common? This portion. Just imagine this entire circle, when you take common with this orange portion, you will get this part. And now is the LHS diagram matching with the RHS diagram? Very well. LHS is equal to RHS, hence proved using Venn diagram. Next question. A minus B, once again same diagram. It's like a half moon. B circle, here it is, B circle, entire B circle. And I want its union also. Oh, whoa. Did I miss one diagram? Yes. Great. A minus B union with B. Let's draw the combination of above two diagrams here. Right, peeps? Green. Combination of above two diagrams. First part and second part, when you unionize, you will get the entire A and B. And here you simply have to mark A union B, that is entire A and B again. Is LHS matching with the RHS? Very well. Hence proved. So guys, I tried covering all the aspects of this chapter sets. Hope you enjoyed learning from me. We'll come up with more sessions, more chapters. The next chapter, relations and functions, also very soon, where in the first part we will go through all the summary notes and second part questions, questions, questions. If you like this format, let me know. If you want that, no ma'am, you take a concept, then questions on it, then concept, question, concept, question, let me know that also in the comment section. I will definitely work upon it. I guess that was all from my side for today. Thank you so much. Take care of yourself. Keep smiling. See you all. Bye-bye. Thank you.